Think about a big restaurant kitchen on a busy night. Every station has a chef, and the head chef has one stubborn rule in her head. Every station must always be staffed. If a cook burns himself, a runner pulls him out, and a backup steps in within seconds. If a chef goes quiet and stops calling out orders, she waits a beat to make sure he is not just busy, then sends someone to cover his station so no dish is dropped. Nobody panics and nobody files a report. The kitchen just quietly refills any gap the moment it appears. That instinct to constantly notice a missing worker and replace them is exactly how Kubernetes self-healing works. Hardware fails, kernels panic, processes leak memory and die, and cloud nodes get reclaimed without warning. In a system with hundreds of pods, something is always broken. If recovery depended on a person noticing and reacting, your uptime would be measured in how fast your on-call engineer can wake up. Self-healing in Kubernetes is not one feature. It is several reconciliation loops at different layers, each detecting a specific kind of failure and correcting it. Container failure, pod failure, and node failure are handled by different components on different timers, and knowing which handles what tells you exactly how fast and how recovery happens. At the container level, the kubelet runs the liveness probe, and on repeated failure it restarts the container in place according to the pod's restart policy. To stop a hopelessly broken container from restarting in a tight loop, the kubelet applies crash loop backoff, an exponential delay that doubles up to a cap of 5 minutes between restarts. At the pod level, a replica set controller watches its desired count and recreates any pod that is deleted or lost. Since a dead pod is never resurrected, a fresh one is created. At the node level, the node controller waits for kubelet heartbeats, and if a node stops reporting for about 40 seconds, it is marked not ready. After a further timeout, roughly 5 minutes by default, the node controller adds eviction taints, and the pods on the dead node are marked for deletion. Those deletions drop the owning replica sets below their desired counts, so their controllers create replacement pods, which the scheduler places on healthy nodes. A pod disruption budget limits how many pods of an app can be down at once during voluntary disruptions like drains, so healing never violates your minimum availability. Stateful set recovery is more careful, recreating pods with the same stable identity and storage so a database replica comes back as itself, not a stranger. A node hosting a 30-pod workload loses power. Its kubelet stops sending heartbeats. After about 40 seconds, the node controller marks it not ready, and traffic already stops flowing to its pods because their readiness can no longer be confirmed and endpoints drop them. After the pod eviction timeout, the dead node's pods are deleted from the API. Each affected replica set now sees actual count below desired and creates replacements. The scheduler binds them to healthy nodes, and within a few minutes the full workload is running again elsewhere, all driven by ordinary control loops reacting to changed counts. 2 myths trip people up. First, that recovery is instant. It is not, because node failure recovery is gated by deliberate timeouts, around 40 seconds to detect plus minutes to evict, to avoid panicking over a brief network blip. Second, that a crashing pod restarts forever at full speed. It does not, because crash loop backoff inserts growing delays up to 5 minutes, which is exactly why a misconfigured app seems to take longer and longer to retry. Tuning those timeouts, not wishing them away, is how you trade detection speed against false alarms. Self-healing is layered loops on timers. The kubelet restarts containers with backoff, replica sets recreate lost pods, and the node controller evicts pods from dead nodes after deliberate timeouts so replacements get scheduled. It is reliable, but it is intentionally not instant. Like the head chef who waits a beat before covering a quiet station, the system pauses on purpose so a brief hiccup is not mistaken for a real failure. I dissect how Kubernetes survives failure, one mechanism a day. Subscribe to TechWithJoel so the next outage feels routine instead of terrifying. What is the longest recovery you have watched a cluster grind through? Subscribe to TechWithJoel.